Welcome and thank you for joining us on this Thursday afternoon or morning, wherever you are. My name is Layla Porter, and I'm going to be talking about TDD and the Terminator, an introduction to test-driven development. So a little bit more about me. I am a Microsoft MVP. I organize my local .NET meetup group, miltonkeynes.net. I love C#, and my day job is as a developer evangelist at a company called Twilio. Now, you may be wondering why this is TDD and the Terminator, and that's a very good question. And to explain this, I need to go back to my job before the last one, so 2 jobs ago. Where I was a software engineer at another cloud communications company, very different type of role than at Twilio, and I was an engineer there. And we had a very high use product, and there were a team of maybe 8 of us working on the one part of the project I was assigned to. And we didn't have a single test, not a unit test, an integration test, nothing. We relied wholly on a team of 6 testers. We had 2 in the office and we had 4, I believe, in the Ukraine. And they were awesome. But it was after one particular test run ready for a release, and I had to sit through 9 weeks of regression bug fixes that I thought there had to be a better way. Why do we keep breaking all of our code? And I started to look into different ways of doing things, because I knew this shouldn't be like this. Releases should be much more smooth, and we shouldn't have all of these regression issues. And so I started to look into testing, and in particular test-driven development. And that felt like it would sit quite well with me. It felt like it would suit the way my brain works and the things I like to do and the way I like to look at code. So I started to get into it a little bit more. And what I found was that it's really hard. You can't really just teach yourself test-driven development by reading some books or watching YouTube videos. I do distinctly remember a YouTube video that I watched, and it looked like magic. This clever guy was whizzing through his code, and he goes, oh, and you just refactor and boom, everything went green. And I was lost and overwhelmed, and I thought there has to be a better way. And I used the analogy of programming a Terminator to teach myself test-driven development, because I could relate to the subject matter. I'm a big fan of the Terminator, as you'll probably gather as we go through this talk. So by creating my own Terminator app, I was able to get my head around test-driven development, and hopefully it's going to resonate with some of you. So let's have a little look at why I like TDD. And I will just put the caveat that this is TDD Successes, and it also applies to some unit testing as well, which isn't specifically TDD. It's a part of it, but you can also do unit testing after you've written your code, and we'll talk about that in a little bit. Okay, so the first thing is acceptance criteria. Now, when you have clear requirements from your product manager or your customer, you can write tests. It also means that you have a clear understanding of the requirements. You have everything that you need to plan to code whatever this feature is or this user story. And without proper, clear acceptance criteria, you can't write tests. So this is really important, and it builds that stronger relationship between you and your product owner, whoever that may be, and you feel more comfortable because you know what's expected of you. TDD gives you focus, and many of us as developers have ADHD. We struggle to focus. Something called shaving the yak is a common term you'll hear with software development. I've got a link to it at the end in the last slide, so you can have a look at what shaving the yak is. But it's you'll be familiar with it. It's like, oh, I just need to do X before I can do Y, but to do Y, I've got to do Z. And before you know it, you've written a whole other service and you've lost focus on the actual requirement that you're supposed to be doing. So by having the one single piece of criteria, shall we say, to code and write a test for, it keeps you super focused and your code nice and clean and tight. Now, I like to think interfaces or coding contracts are really a part of TDD here. And I take a very pragmatic approach to TDD rather than a dogmatic, and this is what suits me. And if you are working in a team and you're working with your coworker, if you have interfaces, that's your coding contract. You're telling your coworker that this is the code I'm going to write. It's going to fulfill this coding contract, and they can get on with their code, and they're not dependent on you. They don't need you to have written all the implementations because you've got these interfaces. You've already written the tests, so you know that these interfaces fulfill your requirements, and you can happily give that over to your coworker to start work on. And what does that lead to? Well, asynchronous development. A lot of the time when I was working at that old company, I would be like, okay, what am I going to pull off the backlog? And we did pseudo sprinting. Our sprints were about 6 months long, so that can tell you a lot. And I'd be like, oh, well, I can't work on that particular user story because these 3 other stories have to be done. And then I have to wait for so-and-so across the office to get that bid and commit that in because I have no idea what they're doing. I don't really know the requirements. I'm not saying that you can't solve this in other ways, but TDD definitely helps assist with this. Now, because you've got focus, you've got clear acceptance criteria and all your requirements, you get cleaner code. Because you are only writing enough code to fulfill a test, you're not going off into, oh, well, I'll just add in a switch here, and I know that I'm going to need this in a little bit. You don't need to write any of that. You just write that clean code just enough to pass your test. Okay, so we also get safe refactoring. So remember that 9 weeks of regression bugs wouldn't have had any of those problems if we had tests, any type of tests. And so you can safely go in and refactor code, which I'll show you later, and without any fear of regressing your code, because if you do regress, all of your tests or whatever tests relate to the bit you're refactoring are going to fail and let you know that they failed. Excuse me. And this leads to fewer bugs because you're not breaking previous code. You know that the code you've written is passing a test, so you can be much more confident that you're not going to have as many bugs. And because you have fewer bugs and you can refactor quicker, you get increasing returns. So you're going to make the product owners and the bosses happy because your workflow will increase, or your throughput is going to increase because everything is smoother. You can code with more confidence. And one final thing that many people don't think about is that having tests is a living documentation. Often written documentation gets out of date, people forget to update it, but your tests can become a living documentation, especially if you write your test names in a very verbose way, shall we say. I'm not saying that tests replace your documentation. However, they're a really good start, and any new developer coming onto your product can go and have a look at the unit tests and they'll know exactly what the code should be doing. And you can also base your written documentation off of your tests. All right, we'll get back to the Terminator now. That's what you're all here for, I know. And let's have a think about the process, bearing in mind what I've said previously. So that process is going to start very clearly with gathering the requirements. So let's gather some requirements. Okay, so my Terminator needs to inspect people, and in this case, it's going to look at this boy on the back of a bike. And I'm going to investigate boys more because they could be John Connor. And in this case, we've actually identified that this is John Connor. So this is our process. This is our requirement that we can inspect individuals and determine whether we should investigate them further. So let's just have a look at that. Our Terminator requirements are scan subjects and determine if they require further investigation, and investigate subjects of interest and determine if they are the target, and terminate if necessary. So let's have a look at that first one, scan subjects and determine if they require further investigation. So what's our next step in our process? Well, we're going to start with failing tests. This is key, absolutely key. Now, when you write tests after coding, you may be writing them to fit your code and not your requirements. So this is very important. If you don't start with failing tests, there's definitely something wrong, and that's a code smell, and you should be thinking, actually, have I already written my code? Oh, yes, I have. So you want to make sure that you're not writing code, because if you are, what might happen is that, let's say, for example, your code returns a status code of 200. You'll write a test for that says, oh, this API must return a status code of 200. Your tests pass, everything's amazing, you're happy. Comes to your testing, and really it should have returned a 201. And you'd have to be going back and checking your requirements. So what you should be doing is looking at your requirements and writing your tests. And then you can go off and write your code, because that will then fulfill your tests, which you know fulfills your requirements. Now, for my tests, I like to employ the red-green refactor pattern. And let's have a closer look at this. You'll write a failing test first, and that will be red on your IDE, which we'll see. And then you write enough code to get the test to pass. I'm just going to say that again because this is key. Just write enough code to get the test to pass. And finally, refactor. So let's head on over to some code, and I will show you how to get started. Okay, so over here, I have a very out-of-date .NET Core 2.2 application. It doesn't matter because everything is more or less the same. I will get around to updating it. And this was just brought in from the base template on the .NET's new CLI. I can't remember what this is. It might just be, I think it's just a class library, but it doesn't matter. It will work with whatever you have. So I have this, let's start here with our interface, which is an I subject. And in that we have a string, and that's a subject name. And we have the implementation of that, which is subject. And that, of course, will have your public string subject name because it needs to fulfill this contract of I subject. I have another interface over here, and let's assume my colleague has handed this over to me, and they've already started writing other code with this contract. So I know that this is what they need, so I'm going to write stuff to fulfill this. And this has a property that returns a method that returns a bool, and it takes a subject or an I subject. And this one is investigate further. And the final thing I have in here is my test class. So I always use it as whatever the implementation is going to be, tests. So subject analyzer tests, but you can name it whatever you want. I happen to use NUnit as my testing framework. You could use XUnit, you could use the Microsoft testing framework. I just happen to get on with NUnit. I've used XUnit, and there's a lot in favor of XUnit because it's more maintained as far as I'm aware. I just like NUnit, so I stick with that, but it doesn't matter. They all have roughly the same features. So this is a decorator here, and this helps the IDE discover your tests. And this is important here. I have the I subject analyzer. So anything that is going to fulfill that interface can be tested in here, okay? And I'm going to call that SUT, and that's subject under test. If this was a more complicated service or something like that, you may have a whole load of injected dependencies, for example. And I like to always call the thing I'm testing SUT rather than say subject analyzer, because it makes it stand out from all of your other privates that you might have in here. So we've got that. And then I have this setup, and I can create anything in here that the rest of my test methods might use. You might only use something in one test method, so you could create, you could use something up, for example, in that one test method. But if you're going to use something again and again, it's best to do it in a setup method here, so you can reuse it. And down here, I've just got our requirements, so we've got those to hand. So the first thing we need is an instance of this. So let's do that. And you'll see that I can't new anything up because we can't instantiate an interface. So we're going to need to create a concrete version or an implementation of iSubject Analyzer. I'm going to call that Subject Analyzer. And I don't want you to make that test. Thank you, Ryder, for the assistance, but not at this moment. And so I'm going to grab this and we're going to make that. I have a services directory over here, so I'm just going to add that over there. So we'll have a new class, and that's going to be called Subject Analyzer. And very importantly, this needs to fulfill iSubject Analyzer. That's why this is getting unhappy, because this does not implement this interface. So let's go and sort that. So we have iSubject Analyzer, and that's unhappy because this still doesn't fulfill this interface. So we can get the IDE to assist us. And what you'll get when you implement an interface is throw new system not implemented exception. Perfect. This is exactly what we want to start with. So we're now ready to write some tests. You can see we've got no red squigglies over here. Everything is really happy to go. So let's go and write our first test. Now, for NUnit, we need to decorate our test methods with test. And these are public voids. And then, not voids plural, we need to give this something descriptive. So let's go with Terminator should, and I like to delimit 3 times, should determine to investigate. I'm going to do a woman first. We're looking for Sarah Connor. Further. Okay. Now, you can choose how you name your tests. I often see a lot of this type of thing here with lots of underscores. I personally don't like it. I like what's happening, what the sort of action is, and the result. So you'll find one that suits you and your team. Okay, so when you've got a test, there's a couple of things you need to think about. First of all is your arrange. Then you have to act, and then you have to assert. So you'll need to fulfill at least 2 out of these 3. So let's have a look at our act first. Alrighty, so we're going to have var result is equal to SUT dot investigate further. All right, so this has got a red squiggle, and that's because it's expecting a subject to be passed in. So that's going to go into our arrange. Now, if you were using this subject again and again, you could set this up in the setup method up here, but we're just going to use it here. So var subject is equal to new subject, and I'm going to create that now. We'll just bring in that. And oh, we want that in there. and we don't need a backslash, and that's going to be subject name equals, and we're just going to say woman. Now, I know testing against strings is horrendous, but this is just to make it nice and clear for you. I wouldn't normally do sort of tests like this, but, or, you know, pass in strings and compare on strings, but we're just going to go with it. And the final thing now is to assert whether the result is as expected. So I use something called fluent assertions, and that's because they're nice and readable. That's my preference. You can use, I think it's Shouldly as another library, or you can just use the built-in assertion, which I'll show you later as well. So result dot should dot be true, because we want to go and investigate a woman in case she's Sarah Connor. So that looks true, that looks good. And now we're ready to go and run our tests. Now I'm going to use the test analyzer up the top here, and hopefully that will go and discover them. Sometimes if I don't clear this, there we go, that's fine. Okay, so we've got subject analyzer tests and it's failed. Let me just move that over. So this is our red, and it's failed because system not implemented exception. Exactly what we expected. So let's go and fix this. Now remember, we just want enough code to pass this test. And feel free to shout at your computer. I won't hear you, but I'll know that you've been answering. What do you think the absolute bare minimum amount of code you need to write to get that test to pass? I hear you all shouting, sort of. I'm imagining you all shouting the answer to me, and that is return true. All right, let's run these tests and see. Boom, it's green. We've done our red, green, and now we'll refactor. So this was the aha moment for me. Just the bare minimum amount of code to get your test to pass. So that was key for my understanding. So hopefully that's triggered some understanding for you all. Okay, so we've got this message, this test method. Let's do another one. And what I'm going to do is just copy this one. Copy and pasting is allowed, says John Skeet, so we'll do that. And we're going to do a negative one. Should determine not to investigate further. So we're hunting John and Sarah Connor, and I bet you there's a T1000 hunting them too. So we're not bothered about T1000. We're all on the same team. Now, yes, I am munging the two movies together, but just go with it. So we've got a T1000 now, and we need that answer to be false. So we can just change down here to be false. That looks good. And this could be anything that you don't want them to investigate. So let's run our tests again. And oh, look, you see it didn't find it because I forgot the decorator. So if your tests don't run, always first thing you should think about is the decorator. And you can see immediately the IDE has picked it up now. And it's failed as expected. Expected result to be false, but found true. So let's go and fix that. Okay, so we are going to have if subject dot subject name is equal to woman, we're going to return true, else we'll return false. Okay, and we're not doing any fancy switches just yet, just we'll do some more of that later. Let's run our tests. Hurrah, it's green. Now, if we go back here, I want to do an investigate a boy. So that's also going to be true. So what I could do is copy and paste this whole method, but it's much better if we use something called a test case. And this is cool because it allows you to pass in parameters or arguments. So this one's going to be woman, and we're going to have one for boy. So you just stack them up. You can have as many as you like. And then we're going to say over here, we're going to have string subject name. And then all we need to do is pop that in there. And we can now see that if I pull this up a little bit, you can see the IDE has said, oh, this test here has 2, but what we should do is just update the name. So we're looking at a more generic name, and then we've got the different test cases in here. So it tells you we're going to pass in boy, we're going to pass in woman. So let's run these. Yeah, oh, that's because, so what's that? It only ran the one I had selected, so we need to have that up here. So you can run individual tests. You can also run them from the margin here, and you can see we had 1 pass, but 1 failed. So let's go back and rectify that. Let's just copy. Let's make a wonderful, attractive if stacking here. Pop that in, and let's just check that. And everything is green. Amazing. So you can see we've quickly started to build on our code. It's very lean, and I know it's not the prettiest code, and you may not want to write this, but hopefully that's showing you a little bit there. So let's go back to the slides. Okay. Now it's time for refactor, and you're thinking, thank goodness, okay, because that wasn't very pleasant code, let's face it. All right, so I have added in a few more potential things to investigate: a woman, girl, man, or boy. And all of these we want to investigate. And what I've done is refactored to a switch, not a fancy new C#8 switch, just an old regular switch. Excuse me. So what I've done is just copied those values over, and now we've got this switch. Great. Now, if we look at our tests, you can see I've stacked all my test cases up, and they're all great. They're all going to work. And if we run that second test there, the T1000, that's going to work too. But these pesky product managers have a requirement change, as they always do. So let's have a look at what our requirement change is. All right, so what have we got going on here? It looks like our T1000 is okay with John and Sarah Connor now. He's not trying to kill them. And what's this? He's learning things. Interesting. Now, I normally ask people to raise their hands if they've seen this clip. And many of you may not have. This is from the director's cut only. And another bit of trivia about this scene, if we see the one where we're in the mirror, so that hand closest to us is actually Sarah Connor's, oh God, I've forgotten her name, my brain's gone back, the actress, it's her sister. And the head we see in the foreground is Arnold Schwarzenegger's stunt double. So it was a very clever scene for at the time, and they faked the mirror. So it actually was people. Linda Hamilton, there, I remembered. So it's Linda Hamilton's sister you see in the foreground and Linda Hamilton in the rear. So there's a little bit of movie trivia for you. So let's have a look at these new Terminator requirements. We've got protect John and Sarah Connor from threats and the ability to learn. Now, the key about the ability to learn is that you saw them taking a chip out of the Terminator's head, and what they did is they switched it from read only over. So now he can learn things. So let's go and have another look at our code. And currently we're saying we're not going to investigate T1000s, but they're kind of the enemy now. So we really do want to investigate T1000s. So if we change our code Oh, well, that's going to be a broken test, which is good. You wouldn't get a regression bug there, but I don't really like going and rewriting my tests, thank you. I don't like to go and fiddle around too much. So that's where designing your application to be more robust comes in. And one way in which to do that is design patterns. Now, any of you who have seen my Twitter profile may know one of my favorite design patterns, and that's the solid principles. Now, I'm not going to go into in depth on the solid principles. That's a whole talk in itself. But we're going to touch on a few of them. So all of them are, as you can see here, we've got the single responsibility, open close, list of substitution, interface segregation, and dependency inversion. So I'm going to refer to various of these principles, but the ones I'm going to focus on first is SOL, or the sunny side of solid. And the first one is the single responsibility principle. And that is where every class or module in a program should have responsibility for just a single piece of that program's functionality. So this is very important when it comes to writing tests. If you've got loads happening in a method, how do you know what to write a test for or where that failure might be? So at the old company where we had no tests, I remember one controller method, I think, had about 800 lines of code in the controller. So it came straight in to that controller, which should be handling a view or maybe an API call. And the whole thing was full of logic. There was data access. It was about 800 lines long. That is not single responsibility. Single responsibility is where it's just one thing. It only does that one thing, and you can test for that one thing. So that's very key. Next one is the open-close principle. Software entities, classes, modules, functions, etc. should be open for extension, but closed for modification. What does that mean? I really struggled with this, and I'm going to show you the example that really helped me understand this, and it keys into writing good code and having your tests there so you can safely refactor into this type of thing. And yeah, I'll show you an example that helped me get my head around it. And the final one we're going to look at is the list-of substitution principle. Objects should be replaceable with instances of their subtypes without altering the correctness of that program. So remember we had that iSubject Analyzer, SUT. Now we could swap any of those implementations that we have for iSubject Analyzer, and our code should still work, our tests should still pass. We may need to change the setup slightly if we want different things to go on, but the signatures should be the same, so it should just be easy to substitute them in and out. So let's see this in action. And we're going to refactor our code. Right, so let's have a closer look. We're going to do some test refactoring first because we broke our tests earlier. So at the moment, we've got our test cases up there, and then we've got our don't investigate further bit of method, okay? And we're going to change that over to this. Now, it's one test method instead of two. And what I've done is created test cases with multiple values in them. And you can see there that it's much cleaner. And so if we have a look at that top one, we pass woman as the subject name, and that still gets passed into the subject model instantiation there. And we also have the outcome. So here I've just used the vanilla assertion here, result.equals, and it's the outcome. So if we run those tests, they all pass. So we've just refactored. We didn't change the code. We just changed our test, updated it, and we've run that all, and it's all fine. So that's really key. Before we go on to our refactor in a moment, we need to make sure that this is all green because remember, it's red, green, refactor. So how are we going to refactor this? And hopefully this will explain some of those principles. Okay, so this is what we have at the moment. We've got that iSubject, we've got the subject that implements iSubject, and we've got our investigate further method on the left, which is part of subject analyzer, and we've got that lovely, delightful switch. Now, we've already refactored that once. Now, what we're going to add is a new interface, and this is called iSubject rule. And this has two methods. The first one being an is match, which takes the subject and that will return a bool. And we have an of interest, which also returns a bool. So it's really important that you have this interface. Okay, so let's go and have a look at what an implementation of iSubject rule looks like. And we'll do this by building it off our switch statement. So the first one is going to be is woman rule. And that, of course, implements iSubject rule. And is it of interest? Well, if we look at our switch statement, we want that to return true. So yes, of interest needs to return true too. And then our public bool is match. This is the really flaky code, so do not use this code in production. So this is going to go and have a look and see if the subject you pass in contains woman. So it's just going to do a little bit of string comparison there, and that really wouldn't work if you had man being passed in, or sorry, woman being passed in, and because woman contains man. So that would just fall flat. So don't use this, but you could go off and use Azure Cognitive Services and do some, face recognition and return a score, and that would be whether you would return true or false. So you could totally go and change that. It doesn't matter how you implement it. It's just, it has the same outcome. Okay, and then we have an is dog rule. And are they of interest? Well, we don't have them on our true list there, so that's going to be false. And we've got that is match, well, if the subject contains dog. Okay, so we've got our two rules. All right, so this is now, we've got investigate further method on the left. And what we've actually changed our code over to be is this on the right. And you can see we've got the investigate further method still there, but we've got a whole lot of other stuff. And we're going to step through this nice and slowly so you can all follow along. And we wouldn't be comfortable doing a big refactor like this if we didn't have those tests in first, okay? So let's bring our rules up on the left-hand side so we can start to step through and see what's going on. So the first vital thing here is we've added this private read-only list of iSubject rule called subject rules. And note how it's a collection of the interface, and that is key. We've now got a constructor, and in that constructor, we're going to new up our list of iSubject rules, okay? And what's special about a list of an interface is it can take any implementation of its interface, okay? So what we've got now is the new is woman rule and new is dog rule. So we've added those into our collection. Now, you may want to new up those rules and inject them rather than newing them up, whatever you want, however you want to bring those in. But this is just nice and simple and shows you how you can add in those two different classes to the same collection. Okay, so we still have our public bool investigate further method. And this time we've changed the innards of this method. So same signature, different logic. And the first thing we're going to do is pull a specific subject rule out of our collection. And I just use a little bit of link there because I'm going to say which one is a match for subject that's passed in. So subject gets passed into the investigate further method, and then we'll loop through the entire collection until we get one that returns true. Okay, and there's a lot more stuff you'd want to put around here, like what happens if null comes back or anything like that. So none of that's in here, just to keep it nice and clean and easy to read for us all. So if I passed in woman, this would go through my whole collection and return the is woman rule, because that's the one that would return true in is match. Okay. And then once we've got that specified rule back, we pass that into this little private method that we've got going on at the bottom. And all that does is return the of interest. So in this case, this is going to return true, and that means this is going to, our investigate further method is going to return true, which is what we want after all. Okay. So a note on that private method down the bottom, because you may be wondering, oh, should that be in the interface? If you need to make a private method public in order to test it, then it's time to refactor. Because if you're going to make it public and test it, then you're almost definitely going to need to add it to your interface. Now, remember my coworker? Well, she's now going to have to go through all of her code, because her code's not going to fulfill her interface, not fulfill that contract. And they're going to have to implement those missing members. And what they might get is this. They might have their class filled with some throw new not implemented exception, because they're like, well, I don't need to do that bit of code. That's superfluous to me. So they just leave them there as throw new not implemented exception. And I have seen this time and time again. I have seen code that has about 30 of these methods, all with throw new not implemented exception. And this is really important where we go over to the id. And this is why you shouldn't just update an interface, you should refactor and make a new one, because the interface segregation principle splits interfaces that are very large into smaller and more specific ones, so that implementations will only have to know about the methods that are of interest to them. So in our case, if we wanted to make that method, let's go back and, oh, I've gone way back now. Oh, right. I don't know why that's gone so far back, but we'll just, oh no, I'm going forward now. Okay, I don't know. Let's go that way. There we go. Okay, here we are. Okay, so if we need to make this investigate method public, we shouldn't add it to the iSubject analyzer interface, because that might mess up our colleagues' interface. What we should do is make a second interface and put that in there, and then subject analyzer will implement two interfaces, because that's the beauty of interfaces. Implementations can implement multiple interfaces, so that's really key. So if you need to do that, don't have this. Extract that stuff out into a separate interface and keep everything nice and small. Okay. So let's go and have a look at our code. So this is our new updated code. We've got our constructor there. We've added some stuff, and oh, look, our tests still pass, because we've got the is woman rule and we've got the dog rule, and that fulfills those. Now, you'll remember that we had more than that. We had, what about man and boy and girl? So how do we add those? Well, we just make new implementations of iSubject rule. And all we have to do to add those to our code is add them in like so. So why does that fulfill the open-close principle? Well, we don't need to go and modify our code to update it. We just extend it. So by extending it, we're adding more rules to the collection, but we don't need to modify the investigate further method for it to still work. So this is a really clean way of making your code extensible and not having problems with regression. It's also a really nice way to implement handlers. I've implemented one recently where I have a message handler or a notification handler, and I have rules for when to send an email, when to send an SMS, and it's all based in rules. And depending on like the status of something, it will loop through and go, oh, when it's this status, I send an email. When it's this status, I'll send an SMS. So it's a really nice way for handling that type of thing. Okay. Now, with good practices, code management becomes infinitely easier. So just look into how you architect your code, both as the big picture and at a much lower level, because it all matters. Now, let's go on to TDD failures. Now, I always feel that there should be at the beginning of the talk and the TDD successes at the end because of, red-green refactor, but that's just me. Okay, so the biggest failure I have seen is people underestimating the learning curve. This is a huge change to your entire way of working or your team's way of working. And just don't underestimate how hard it is to switch over to doing test-driven development. I often see TDD confused with unit testing. I remember I did a Twitter poll last year and I said, who does TDD or something along those lines? And someone got back to me and said, oh yeah, I like to write they replied yes, and then said, I like to write my code and then I do some tests. And I was like, that's unit testing. They're not the same, okay? And you choose whichever way works for you, or a combination of the two. That's okay too. Thinking TDD is enough testing. I've seen this too. I worked at a company, the one before Twilio, and they just had TDD and they didn't bother with other testing. They didn't have integration tests. They didn't have any like testing teams. Us as the developers didn't have allowance in our sprints for testing each other's work and that. So TDD isn't enough. And not starting with failing tests. If your tests are passing, then you've probably written too much code. And how do you know that you're fulfilling your requirements with your code? So you just want to be aware of that. Not refactoring enough. So just bodging your code or adding a method to an interface. There is the rule where you can over-engineer stuff. Bear that in mind, and remember this is pragmatic, not dogmatic. And the final one is not actually doing TDD. I have fallen foul of all of these. When I first started my first job doing TDD, I used to write a test and then go and write some code, and then be like, oh, well, I know I'm going to need to do this next. And I do another bit to it and another bit. And then I'd be like, oh, I've written a load of code. I better go write the tests for them. So I was sort of half doing TDD, half doing unit tests. And that's okay when you're learning and getting there, and just be kind to yourself. So let's have a look at implementation within your organization. It can be controversial and is a significant culture change. Do not underestimate the culture change in this. It is a totally different way of looking at stuff. You will need to be pushing back on the product owners to get more refined acceptance criteria or requirements. You're going to have to be saying, nope, I can't work on this particular user story because you haven't given me enough detail to write my tests. I don't know what you want. So it can be controversial. It can also be controversial because there is an initial drop in productivity, and that can be disconcerting both for developers and for product owners, okay? Now, why is that? When you start switching, there's a lot of boilerplate that you have to do. So you have to start writing tests and putting in test products, and maybe you want to put test coverage on your build server, and there's lots of stuff that goes into it. And when you just got someone breathing down your neck to just produce this new API endpoint, you may be tempted to cut corners and not do TDD. However, if you do TDD, you can rest assured that you've fulfilled your requirements. And then if you come back, you've got your tests then as well. And if the requirements change and you come back and do regression, not a regression test, you come back and refactor your code to meet new requirements, your productivity will go up because you're not going to have regression bugs. You can quickly refactor some code with confidence, knowing that you haven't broken anything else. And this is so vital that you can just go. And I've seen it where you get into the rhythm of TDD and you can turn user stories around so quickly. And another great thing is this increased understanding of requirements and their acceptance criteria. So you know what the product owner wants and they know what they've agreed to what you're going to give them. So that works with external customers or internal customers as well. And it's really a powerful tool in your tool belt to say, this is the criteria you gave me, this is what you said would be acceptable, and that's what I have fulfilled. Okay, so it can help limit scope creep and things like that as well, which if you're in like agency work, that can be really, really important. So there is one thing I would like you to take away from this talk. And if you take nothing else, I just really hope you take this one thing away. And that is, if your code, if the simplest, smallest piece of code is to return true, then just return true. And that really was my aha moment. So I hope that's helped you, and that some of this maybe has helped flip some switches in your brain, because that's what did it for me. It was really amazing. And remember that this is my view of how to do TDD, and you will hear lots of different opinions. And the idea is that you choose the methods that suit you and your team. And it may be a little bit of what I do, it may be a little bit of what someone else does, it may be something that you come up with yourself. There is no right or wrong way to do this. You may want to be more dogmatic about it and more regimented, or you may want to keep it a more pragmatic approach. You'll find your own way that works for you and your team. So with that, I'd like to say thank you. You can find me on Twitter at Layla Codesit. My GitHub name is Layla-P. You can email me on lporsche@twilio.com. Now, if you want to see the repo for this code, you can go to that bit.ly link there. If you want the deck, you can get it there. You can also go see some Twilio on twilio.com if you're interested in learning more about what we do there. And if you want to know what shaving a yak is all about, then there's that link down the bottom, which is the best shaving a yak analogy, I think. So have a look at that and you can have a read through, and it will click with you. You'll know exactly what I'm talking about. So yeah, thank you so much for joining me and giving me your time. So over to you, Martin.
Yes, thank you, Layla, for a very, very good presentation. There's lots of questions, so we won't be able to tackle them all, but I think I managed to compile a nice list of things to look into.
Okay.
Let's start with the most important thing, and that is, what is the editor font that you were using for the cursive codes examples in your presentation?
It is Dank Mono. So if you go on my Twitter, I will share that. Let me just write a note to do that. It's a paid for font. It's very popular in the OWL, I think Night Owl VS Code, but it's called Dank, D-A-N-K space mono. And to get the cursive, you have to turn the cursive on. There's all instructions on how to get there. It's a beautiful font to use, and I have it in my IDEs as well. And I just find it makes it very readable for me, and I enjoy working with it. So I think it's about €35, well worth it. You get updates and everything. So yeah, that's the font I'm using.
All right, cool. Then a more technical one, which is, how would you use TDD to test complex programs that connect to external data sources and methods that create and modify data? Like, would you connect to a database? Would you mock out your database connection, or how would you go about making that work properly?
So testing data is one of the hardest things to do in TDD. So I'm going to give you a whole range of possibilities. The first is that you agree with your team that you're not going to write tests with that. That's probably the easiest solution without doing that, not necessarily a recommended one. But some people will say, okay, we are not going to test the repositories and the data, and I've seen that done. The next thing is you could use in-memory database. So there's a NuGet package for like in-memory, entity framework in-memory. If people want me, I can give it to you. I can't remember the NuGet package. And so what you can do is you can create this in-memory database, and then you can query it, you can add to it, and then it just disappears when you stop running it. So that's another way you can do that. So you'd have to seed it. So that's quite a nice way of, really testing it extensively. You may want to use that if you're doing integration tests as well. And the third way, which can be tricky, is using mocks. So I use mock, M-O-Q, for mocking anything in there, and you can mock the expected response from a method, and you can say exactly what you think it should return, and you can test that maybe your service is doing exactly what you would expect with that. Or if you've got some operations that happen to your data, you could sort of mock that and bring it back, but it's very difficult to mock the context. If you go onto Stack Overflow, you will see so much about this. It's one of the most frustrating aspects of TDD and the most complicated. So hopefully that answers the question, sort of.
So the answer was basically, it depends a little bit.
Oh yes, I hate saying that, Martin. Yeah, it does depend on how complicated your data is. I tend to err towards mocking. That's worked very well for me. And then the seeding of an in-memory database can be very, very easy. It takes a little bit of work to get it seeded how you like, but that's also good because if you're doing tests like that, you're not using it on live data and things like that. So you can anonymize data, which obviously fulfills GDPR as well. If you accidentally are testing, if you're running and you've got your real context in there, I'm trying to think how you would do that. But if you're very strict and only use in-memory stuff, you're not going to have as many accidents. You can't screw over that database or corrupt your data.
All right. Let's maybe switch over to code coverage now. And that's probably also going to be one of those it depends kind of questions. But how would you design test cases to achieve better coverage overall?
I guess I would, if you have a test team, I'd work with your tester and get them to think outside the box. They're very good at thinking outside the box and giving you odd scenarios that you as a developer may never think of. It's always good to pop your code in for code review and get your co-workers to have a look and go, what happens if you do this? So definitely getting other opinions on better code coverage, like what would happen if this was void, for example. You should be handling all of that type of thing, but it's more the unusual edge cases that you want to do. And you can always, if an edge case comes up and you haven't handled it, you can always add in a test for that, and you've learnt for future requirement changes and updates to the code. So don't be afraid to, if you find something, to add that into your tests. So you can also, if you have a build server, you can set up code coverage, which means that you can only ever increase your code coverage, and that will enforce that each developer is writing enough tests for each new edition of code they're doing. You will come across problems. I came across a problem where I kept failing on my push because I had added in automapper. And obviously you don't write tests for other people's work. So you don't write tests for, that's probably a key bit of information. You wouldn't write tests for a NuGet package, but your code coverage on your build server might go, oh, hey, you've just added a whole load of code and there's not enough tests for it. So you need to go in and whitelist so your NuGet packages and things. So you need to be aware of that could throw you.
All right. And do you sometimes find that having high code coverage means that there's additional maintenance overhead in your code base, or does that not really come up?
I think it can, if you're trying to work quickly, it may ruffle some feathers because someone's like, oh, I've written enough tests, I just need to commit this. And then you can talk with whoever's controlling your code coverage and say, could you just let this one through? I think it doesn't really add that much maintenance. It's just ensuring that you have a good standard of quality to your code. There are going to be things that you have just exhausted it, and whatever you're using for your code coverage is going to go no, so you just have to manually go in and change that or update the rules for it. But I don't think it adds that much overhead.
Right, I think that answers the question. There's two more that I want to cover.
Okay.
One is around the cultural implementation challenges that you also mentioned. How would you introduce TDD in an environment where you are the only one doing it? Or how do you convince people that repeatable testing is actually fundamental to avoid regressions?
So I think you'd want to choose the right moment to introduce it, where there's been an issue, and be like, actually, can I share what I've been doing? Maybe in a brown bag session even, so people have an understanding of what you do. I think that always helps if you do like a brown bag lunch session, so you can get everybody to look at your code and share your screen, and give them an idea of what it can do, and talk about the benefits. Also be honest about where they're going to have some pitfalls, and that they're going to have a little bit of a slow start to it, and it will be a little bit frustrating. I think the real big help that I've found is pair programming, and pair people up, and they can help solve it themselves. They can keep each other honest that they're writing the tests first. And that's how I would do it. But you'll have to make sure that people are aware you're going to adjust the number of points you bring into your sprint, for example, because you're not going to be as efficient when you first start. So you're going to have a drop in productivity. Just be very communicative. Tell product owners that we're introducing a new system and we're going to have a drop in productivity now, but it's going to go up rapidly as we get into the swing of things. So I think just being honest and communicative and kind to each other and supportive is the way to do it.
As always, communication. Yep, I'll start with the last one, and that's a question that we got from probably our youngest attendee who is watching right now. And he says, I'm 10 and I'm learning computer programming in C# with my dad. What do you think the first step to learn and the first program I should make with TDD?
Okay, so I have some experience teaching 10-year-olds, and what I did was help them create a text adventure game in a little console app. And so that would be a nice app to build with TDD, because say you have a yes, no answer for do you want to go into the cave or do you want to go and slay the dragon? You can easily imagine what that is. You know what the story is that you want to tell. And that's what Terminator did for me. I knew the story that I wanted to tell. And I think text adventure games are a great way of learning new bits of code and starting with that, because you know where you want to go. So with that, you could say, okay, so the first step is I want to ask the player, do they want to go into the cave or not? And then your tests would be like, if they go into the cave, this should happen. If they choose not to go into the cave, this should happen. And you can start to write your tests like that. And your tests will tell your story and help you write your code. And I think that's a really nice way to start it. Hopefully that might help.
Cool. Thank you, Layla. Yep, let's again thank you for presenting and thank the audience for joining us today.